In this episode, we are moving into a topic that many beginners find exciting at first because security tools are often the most visible part of a cybersecurity program. They have names, dashboards, alerts, reports, and price tags, so it is easy to assume that better tools automatically mean better security. Real security management is more complicated than that, because a tool only becomes valuable when it supports a real business need, fits the environment, and is used well by the people responsible for it. That is why selecting and implementing security tools and technologies is not mainly a shopping exercise. It is a decision process that connects risk, operations, budget, architecture, staffing, and long-term maintenance. When leaders understand that connection, they stop asking only which product looks strongest and start asking which technology will reduce meaningful exposure, improve decision-making, and remain workable for the organization over time. Before we continue, a quick note. This audio course is a companion to our Course Companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A security tool is any technology used to help prevent, detect, investigate, respond to, or recover from security-related problems. Some tools focus on identity and access, some watch endpoints, some collect logs and help analysts understand activity, and others support encryption, backup, email protection, vulnerability management, or vendor oversight. A security information and event management (SIEM) platform, for example, helps gather and analyze security-relevant data from across the environment, while an endpoint detection and response (EDR) platform focuses more directly on suspicious behavior at the device level. A beginner does not need to memorize every category to understand the larger point. Organizations buy security technologies because they need help seeing what is happening, controlling who can do what, reducing common weaknesses, and responding faster when something goes wrong. The wide variety of tools exists because no single technology solves every security problem, and because different businesses face different risks, environments, and operating demands. The strongest tool decisions begin with the business problem, not with the vendor presentation. This is one of the most important lessons for new learners because many organizations waste money by selecting technologies before they have clearly described the risk they are trying to reduce. A company may feel pressure to buy a new monitoring platform, an identity solution, or a cloud security product simply because those categories are popular or because competitors use them. That approach usually leads to disappointment because the technology was chosen before the need was properly defined. A better starting point is to ask what the organization is struggling with right now. Perhaps visibility is weak, access control is inconsistent, vendor oversight is growing harder, or incident response is too slow and fragmented. Once the problem is expressed in plain business and operational terms, the search becomes much clearer. The organization can then look for technology that addresses a real gap instead of hoping a new tool will somehow create its own purpose after it arrives. That same discipline should continue when requirements are being defined, because selecting a tool without clear requirements is like buying a key before you know what lock it needs to fit. Requirements should include not only what the technology must do, but also how it must fit into the organization's broader operating reality. A security leader should consider coverage, scale, reporting needs, ease of administration, support for current platforms, data handling expectations, regulatory concerns, and whether the tool will work for the teams who actually have to run it. A product that looks impressive in a demonstration may still be a poor fit if it requires more staff time than the organization can provide, or if it supports only part of the environment that matters. Good selection work therefore blends technical, operational, and business requirements together. That makes the decision stronger because the organization is no longer asking only whether a tool has a feature. It is asking whether the tool can support real risk reduction in the environment that exists today and the one the business expects to have tomorrow. Integration deserves special attention because tools rarely live alone. Most organizations already have identity systems, logging pipelines, cloud platforms, collaboration suites, endpoints, ticketing processes, and vendor-managed services that a new technology will need to work alongside. If a product cannot exchange useful data, inherit context from other systems, or fit cleanly into existing workflows, then even a capable tool can become frustrating and expensive. An application programming interface, API, is one common way technologies share information, but the larger lesson is not about technical detail. It is about connectedness. Security management becomes weaker when each tool creates its own separate island of alerts, policies, and administrative effort. Stronger programs aim for tools that can support a more coherent operating model, where data flows sensibly, ownership is clear, and the team does not have to recreate the same information manually in 3 different places. Integration reduces blind spots, lowers friction, and helps the organization avoid a situation where technology volume grows faster than the team's ability to understand and govern it. People and process matter just as much as product capability, and this is where many first-time buyers get surprised. A tool may be technically powerful and still deliver very little value if no one has time to tune it, review its output, respond to its findings, or keep its rules and assumptions current. Security managers should ask early who will own the technology, who will administer it, who will review exceptions, who will respond to alerts, and how decisions from the tool will fit into existing workflows. Without those answers, implementation becomes shallow and the technology often ends up running in the background while the organization assumes it is providing more protection than it really is. This is also why automation should be viewed carefully. Automation can save time and improve consistency, but it does not remove the need for judgment, ownership, or process design. Good leaders know that a useful tool is not simply installed. It is operated, interpreted, maintained, and connected to human decisions that make its output meaningful. Vendor evaluation is another important part of selection because the organization is not just choosing software. It is also choosing a business relationship that may last for years. Leaders should consider whether the provider is stable, whether support is responsive, whether the product roadmap appears sensible, and whether the vendor's own security practices are strong enough for the role the technology will play. A tool that handles sensitive data or supports critical functions should be examined with the same seriousness the organization would apply to other major third-party dependencies. Contract terms matter here as well, including service expectations, responsibilities during incidents, data ownership, and how the organization would exit the relationship if the tool no longer fit its needs. A service level agreement, SLA, can help define parts of that relationship, but the broader lesson is that choosing a technology often means inheriting a long-term dependency. Mature leaders evaluate the provider, not just the feature list, because a good product backed by weak support or poor governance can become a lasting operational problem. Cost should also be viewed in a broad and realistic way, because the price of the product itself is rarely the full cost of the decision. A technology may appear affordable during procurement and become much more expensive once implementation labor, integration work, staff training, consulting support, data storage, tuning effort, and recurring renewals are considered. This is why total cost of ownership, TCO, is such a useful idea in security management. It helps leaders think beyond the initial purchase and consider what the organization will actually spend to make the technology useful over its life. Hidden cost is one of the main reasons tools underperform. A team may buy something promising, then discover there is not enough money or time left to configure it properly, train the right people, or sustain it in a healthy way. Good selection work takes this seriously from the beginning. A tool that costs more upfront may still be the better choice if it reduces manual effort, fits the environment cleanly, and stays manageable without constant outside help. Before committing fully, many organizations benefit from a limited evaluation period that tests whether the technology works well enough in the real environment. A proof of concept, POC, is often useful for this reason, but it only adds value when it is designed carefully. The purpose is not to let vendors perform a polished demonstration under perfect conditions. The purpose is to learn whether the tool solves the actual problem the organization defined at the start. That means the evaluation should use realistic use cases, representative data, normal users or administrators, and clear success criteria tied to business need. If the company wants better visibility, the evaluation should test whether the tool truly improves visibility in a way the team can act on. If the goal is to reduce friction in access management, the evaluation should reveal whether the tool improves that process without creating confusion elsewhere. A strong POC prevents expensive mistakes by exposing gaps in fit, complexity, and usability before the organization is deeply committed. Once a tool has been selected, implementation should be treated as an organizational change effort rather than a simple technical handoff. This matters because even well-chosen technology can fail if it is introduced too quickly, with unclear ownership, poor sequencing, or weak communication. A thoughtful rollout usually includes defined goals for the first phase, realistic timelines, stakeholder awareness, and a clear understanding of what will change for users, administrators, or supporting teams. Some implementations work best in stages, especially when the organization needs time to learn the tool, refine workflows, and reduce disruption. A phased approach can also help the team measure early results and adjust before wider adoption. Leaders should resist the temptation to declare success simply because the technology is live. Live and effective are not the same thing. Implementation becomes successful when the tool is producing useful outcomes, the affected teams know how to use it, and the surrounding processes have been updated so the organization can actually benefit from what the technology is capable of doing. Adoption is often the quiet deciding factor between a tool that improves security and a tool that creates frustration. If the technology is too noisy, too confusing, too intrusive, or too difficult to operate, people will find ways around it or will use it so poorly that much of its value disappears. A classic example appears with multi-factor authentication, MFA. Stronger authentication can greatly reduce identity-related risk, but if the rollout is careless, communication is weak, or exception handling is messy, users may become resistant and support teams may be overwhelmed. The same pattern appears across many categories of security technology. Analysts ignore alerts when the signal is weak, administrators delay updates when the interface is painful, and business teams avoid approved processes when the tool adds too much friction without visible benefit. Good leaders plan for adoption intentionally. They provide training, explain the reason for the change, gather feedback, and adjust workflows when needed so that the tool strengthens secure behavior instead of pushing people toward workarounds that weaken the program overall. Post-implementation measurement is essential because organizations need a way to tell whether a tool is actually reducing risk or simply adding activity. A key performance indicator, KPI, can help show whether the technology is operating as intended, whether adoption is improving, or whether key workflows are becoming more reliable. A key risk indicator, KRI, can help show whether the underlying exposure the tool was meant to address is moving in the right direction. For example, a new monitoring platform might be evaluated not only by how much data it collects, but by whether meaningful detection improves, whether investigation time decreases, and whether major gaps in visibility are shrinking. A new access technology should be judged not only by how many accounts it touches, but by whether privilege is better controlled, review discipline improves, and identity-related exposure becomes easier to manage. Strong measurement ties the technology back to the original business problem. That prevents the team from mistaking busyness for progress and helps leadership decide whether the investment is delivering the kind of outcome that justified the decision. No tool stays perfect forever, which is why lifecycle management is part of implementation success rather than something separate that can be ignored until renewal time. Business needs change, technology environments evolve, attackers adapt, and vendors shift their products in ways that may or may not still fit the organization well. A tool that made sense during one stage of growth may become too limited, too expensive, too isolated, or too complex during the next stage. Mature programs revisit these decisions periodically. They review whether the technology is still aligned with risk, whether usage remains healthy, whether support is adequate, and whether overlapping tools are creating unnecessary sprawl. Lifecycle management also includes retirement. Sometimes the best decision is not to keep adding more technology, but to simplify, consolidate, or remove tools that no longer provide enough value. This is especially important because every tool creates governance work, ownership expectations, and dependency. When organizations manage the full lifecycle thoughtfully, they avoid the common trap of accumulating security technologies faster than they can govern them responsibly. By now, the larger picture should be clear. Selecting and implementing security tools and technologies is not mainly about finding the most advanced product or the longest feature list. It is about choosing technology that fits a real business need, supports meaningful risk reduction, integrates with the existing environment, works for the people who must operate it, and remains sustainable over time. Strong decisions begin with the problem, move through requirements, cost, vendor evaluation, and careful testing, then continue through implementation, adoption, measurement, and lifecycle review. For a new learner, that is one of the most valuable ways to think about security technology as a management topic rather than only a technical one. Tools matter, but they matter most when they are connected to people, process, ownership, and business purpose. When that connection is strong, technology becomes a force multiplier for the security program. When that connection is weak, even expensive and impressive tools can become little more than complicated noise.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.